Yes, you're welcome again to Seremba Online School. This is a continuation of our topic, current electricity, and this is lesson 2. Remember, as I was introducing the topic in the previous lesson, I listed for you some of the terms, and we tried to define some terms in the previous lesson. But now we are going to another term we call resistance of a conductor. Today we are going to start with this term, resistance of a conductor. This resistance, to resist is like you are trying to oppose. You're trying to, rather you are trying to reject something. So meaning that resistance is the opposition to the flow of current within a conductor. That is resistance. So the SI unit of resistance is an ohm. As you see it, this is the symbol we use to denote an ohm. So I will tell you what an ohm is. Then potential difference. What is potential difference? Potential difference is the work done in joules, okay? Work done in joules in moving a charge of one coulomb from one point of a conductor to another. From one point of a conductor to another. And the SI unit of potential difference is a volt. We are going to see what a volt is. I can give you an example. If this is our resistor, remember this is the symbol we used to denote resistor. Assuming that this is a wire, and this is our resistor of maybe resistance R. This is a resistor. Are you getting it? Maybe a certain standard resistor. I don't know its resistance. Then I have a point here, maybe capital A, and a point capital B. Then I can ask you like to find the potential difference, the voltage from here up to there across this resistor R. That's what I'm talking about as potential difference. It is between 2 points. It is work done in joules in transferring a coulomb of charge from one point of a conductor to another. In this case, a charge is being transferred. For example, maybe if current is entering via this, so charge will be transferred from point A to point B. So in this case, this is potential difference from here up to there. For example, if this is like a 2 ohm resistor, it is a 2 ohm resistor. For example, I can say that the PD is abbreviation of potential difference, that the PD across the 2 ohm resistor is 5 volts. Are you getting it? So that is the potential difference between two points. In that case, SI unit is volt. Now we are going to see what a volt is, what a resistance of a conductor is. But briefly, in resistance, I can talk about some of the factors affecting resistance of a conductor. Some of the factors affecting resistance, we have temperature. Briefly, we have temperature. How does temperature affect resistance of a conductor? So resistance is directly proportional to the temperature. In other words, if the temperature of a conductor increases, the resistance also increases, and vice versa. We also have the length of a conductor. Length of a conductor. In this case, length of a conductor is also directly proportional to the resistance. Length of the conductor increases, that means that the resistance is also high, and vice versa. Also, we have the cross-sectional area. Cross-sectional area of the conductor. Now, in this case, resistance is inversely proportional to the cross-sectional area of the conductor. In other words, what am I trying to mean here? If the cross-sectional area of the conductor is large, that means that the resistance is small, and vice versa in that case. Then let us come to the ohm and a volt. Between these two, we have an ohm, and we have what we call a volt. Are you seeing those two? Remember, let me begin with a volt, because it is going to be very simple for us. Look at our definition. In our definition for potential difference, what just I'm going to based on, I said work done in joules. In this case, for a volt, it must be 1 joule. It must be 1 what? 1 joule doing that work to transfer a charge of one coulomb from one point of a conductor to another in a circuit. That is a volt. Therefore, you can say that a volt is a potential, note this down, a volt is a potential difference between 2 points when 1 joule of work is done in moving a charge of 1 coulomb from one point of a conductor to another. Or you can say from one point to another in a circuit. Full stop. That's the definition of a volt. Then we can go to an ohm. Are we together there? We can go to an what? An ohm. Remember, an ohm is the SI unit of resistance, but that's not the definition. There is something I'll talk about, but there's a relationship between voltage and current. Are we together? But that one I will talk about it in Ohm's law. But in this case, we shall see what this one means. V is equal to I what? IR. But I just want to use it to define maybe an what? An ohm in this case. Resistance will be the same as V over I. Resistance is the same as V over I. I will talk about it in details. It will come in Ohm's law. Don't worry. So if I have potential difference when it is 1 volt, and I have current when it is 1 ampere, this means that resistance will be 1 divided by 1. I will get 1 watt, 1 ohm in this case. 1 ohm. So what is that 1 ohm? Okay? An ohm, I'm going to just use this mathematical relation to define it. An ohm, where is the SI unit of resistance? So we say an ohm is a resistance of a conductor. We can say an ohm is a resistance, note this, note it. An ohm is a resistance of a conductor, through which a steady current, I can call it through which a steady current of 1 ampere, flows when the potential difference, are we together there? When the potential difference across its ends is 1 volt. When the potential difference across its ends is 1 volt. For example, look at this resistor. Assuming that the resistance here is 1 ohm, and also the PD, which is our potential difference from here up to there, is 1 volt. Then the combination of the two, when you combine, current 1 ampere is flowing, then potential difference is 1 volt. That means you get an ohm. So we are going to stop here, and in our next lesson I will talk about what we call the Ohm's law in details. Then I will explain more about this equation. Thank you for watching and listening to us.